Okay, welcome back to my channel. I'm glad to have you there. As JAMB is drawing closer, just 2 days before JAMB, or 3, I want us to look at some of the frequently asked questions, probably the top 8 most asked questions by JAMB across different topics. Now, the first one we have on the board here is, of course, this one is coming from light. This one says, a lens with focal length of 20 cm forms a real inverted image 60 cm from the lens. What is the object distance? Now, solution. The first thing we'll do is ask ourselves, the first thing there is, what type of lens is this? They didn't mention the type of lens. They neither told us that the lens is a concave lens nor convex lens. But they said the lens produced a real inverted image. Now, if we come to look at some of the characteristics of the two lenses we have, there are two lenses, the concave lens, and then second one, we have the convex lens. So the properties of a concave lens. One of the properties of concave lens is that concave lenses most times they form. In fact, concave lenses form virtual images. Concave lenses they form virtual images, and the images are always diminished. Now, if you look at some of the characteristics of convex, of course, then we'll call it convex, or we'll call it a converging lens. Now, one of the properties of a converging lens, one, they form real images because they have a real focal length. So I'm not going to waste more time on this. For details on these two lenses, please see the link in the description below. Now, one of the properties is that this one forms real images, and then it also forms an inverted image. So because of this, that lens is a convex lens. And of course, a convex lens has positive, it produces a positive image, and then 2, it has a positive focal length. So because of that, we'll now say that the focal length f is positive 20 cm. Or from the conventional side, really it's positive. So from there, you can pick it up there. Really it's positive. So f is positive. Now forms a real image. The image there, v, is still positive 60 cm. Now the distance of the object is what we shall find out. Now from here, we'll now have that, permit me to clean here, we have that the formula 1 over f is equal to 1 over u plus 1 over v. Now this is the conventional formula. Now this one is positive, this one is positive, therefore this formula holds. Substitute into this. If you substitute into this, we have 1 over 20 is equal to 1 over u plus 1 over v. V is 60. You'll put it there. Now, if we make u the subject, we have 1 over u is equal to, this one is already here, 1 over 20. Now, if we set this one here, it becomes minus 1 over 60. Now, the LCM of 20 and 60 is 60. Now we have it here, 60. 20 divides 60, which will give us 3. 3 times 1, 3, minus 60 divides 60, 1. 1 times 1, 1. Therefore, 1 over u is equal to 3 minus 1, it will give us 2. 2 all over 60. And of course, u is equal to either by cross multiplication or you take the inverse. Inverse means turn upside down. So u will now give us a 60 over 2. And 60 over 2 will give us a 30 centimeter. Therefore, the correct answer option there is option C. Option C is the correct answer option. Now, let us take another one. Take a look at this second question. And this question says, the constant temperature at which a liquid changes into gaseous state is known as, just straightforward question. A, evaporation. B, boiling point. C, melting point. And D, dew point. Now, I will explain these terms one by one because in an exam situation, you may not be able to distinguish one from the other. I will start from this. Now, dew point. Of course, dew point is nothing but, it is all of them occur at certain temperature. Now, dew point is temperature at which air becomes saturated to water. Of course, to vapor, please. The air here turns to saturated water or vapor or water content. Now, in that case, this one is off. This one is off because they say changes into gaseous state. Now, if you come to melting point, yes, both melting and boiling, they occur at constant temperatures. But the difference is that between the two is that for melting points, it occurs at a constant temperature, whereby or at which solid becomes liquid. In other words, this one is off. Now we look at boiling. Boiling, from the definition, boiling point is nothing but a certain temperature, a constant temperature at which liquid turns into its vapor state or into its gaseous state. Now we take a look at the evaporation. Yes, evaporation and boiling, they have something in common. They occur at constant temperature for boiling, whereas for evaporation occur at a temperature below the boiling point. This one at constant temperature. So in other words, the correct answer option here is boiling point, because at boiling point the temperature remains constant, whereas this one, evaporation can occur at any temperature, even below room temperature can occur there. But for this one, it occurs at a constant temperature, whereby liquid turns into gaseous state or into vapor state. Okay, let us also take a look at another one. Third question here. And this third question says, an object moves in a circular path of radius 0.5 meters with a speed 1.0 meters per second. What is its angular velocity? We have option A, B, C, D. How do we solve this? Solution. Now, and of course, this question is from circular motion. Now, from this, we have that if an object is moving in a circle of radius, R there is 0.5 meters. With the speed, of course, there are two speeds if a body is moving in a circular orbit. Let's say, assuming a stone is tied to one end of a string and it is whirled round in a circular orbit, in a circular path. Now, if the stone cuts the object will move in this direction. Now remember here, this is the center. Now we have that here is the radius from the center. Now if the object is moving along a circle, it has angular velocity. Now the moment the stone or the rope or the thread cuts, it moves in a straight line or at a tangent. At this point now, we now have the linear speed at this point. So from here now, we say that the velocity, this velocity is linear velocity, of course, from the SI unit is linear velocity, 1.0 meters per second. And they said, what is its angular velocity? Angular velocity, the velocity that keeps it moving around along a circular path. So omega is unknown. And of course, from simple harmonic motion, there are lots of formulas we have. That reminds me, there are formulas that you need to know before you go into that exam. And of course, one of those formulas is the one that says angular velocity is the linear velocity is equal to omega r, or linear velocity is equal to omega a, where r is the radius or the distance. A is also the distance or the amplitude. So these two formulas are the same. But because they mention radius from here, that is why we are using radius. So in other words, if we use this equation here, we make angular velocity the subject. Therefore, angular velocity will now give us linear velocity all over the radius, which will now give us, if we substitute these two parameters into this, we have that V is 1.0. Of course, 1.0 is something as 1 all over R. R is 0.5. And of course, inverse 1 over 0.5 or 1 over half, which is something as writing 1 over. Of course, we know that 0.5 is half. 1 over half means inverse of half. Inverse of half means turn this upside down, which will give us 2 over 1. And 2 over 1 is something as writing 2 radians per second. And of course, 2 radians per second is option C. C is the correct options. Now, we'll also take another question. We take a look at this first question. Now, this question says, marching soldiers crossing a suspension bridge are usually advised to break their steps to avoid damaging the bridge owing to oscillation, resonance, swinging, vibration. In fact, 1, 2, 3, they mean the same thing. They mean the same thing. Because oscillation, but either, of course, oscillation can be either to and fro, can be back and forth, it can be up and down. Now, in this case, this one is off, this one is off, this one is off. Now, let us take a look at resonance. What is resonance? And of course, resonance occurs when one body sets another body into vibration so that it starts to vibrate at its own natural frequency. Now, in this case, the marching soldiers are advised to break their steps. Reason, once marching soldiers, once they are marching, of course, they set the bridge into either oscillation or into vibration. Of course, when the frequency of the bridge becomes equal to that of the steps of the marching soldiers, then the bridge can now oscillate violently at maximum amplitude. And when such occurs, of course, when resonance occurs, it can set that bridge into oscillation. And the oscillation, when it oscillates at its maximum amplitude, then it can lead to collapse at the bridge. That is why batting soldiers are usually advised, once they are approaching the bridge, they should break their steps, or even move in groups, so that they cannot cause resonance to occur. Of course, with bridges, it can be flyovers, it can be whatever, but as far as it is a suspension bridge, they must break their camp with their steps, so that they don't break the bridge. Okay, we'll take another question. We'll come again. Now this question says, at what respective values of x, y, and z would the unit of force, the Newton, be dimensionally equivalent to m raised to power x, l raised to power y, t raised to power z? And of course, we have these values here. Now, this question is very simple. If you see these, count down, understand the equation first. Now, the only thing they need here is the SI unit of force. They have given it to you in Newton. Now, what is the dimension of Newton? Simple. That is what you are asked to get here. Now, in this case, we now have a solution. We have that force is equal to mass times acceleration. That is a expression for mass, for force. Now, we take the SI unit. Mass is measured in kilograms. Acceleration is measured in meters per second squared. Now, we have, at this point now, you can introduce the dimension. Now, what is the dimension for mass? The dimension for mass is m. Now here we still have m also here. Now acceleration, sorry, the dimension for acceleration, because acceleration is meter per second squared. Dimension for acceleration is lt raised to power minus 2. That is the dimension for acceleration. Now, if you bring the two together, we now have mlt raised to power minus 2. Now, in this case, we know that ordinarily t is raised to power minus 2, l is raised to power 1, m is raised to power 1. Therefore, we now have, even though it is inappropriate to write m raised to power 1, l raised to power 1, yt raised to power 2. Now, in this case, you can now equate this or compare this with this. So in other words, we say compare m raised to power 1, l raised to power 1, t raised to power minus 2 with what you were given, m, x, l, y, t, z. If you compare this, we can now have that x, this one is this, or either you compare or you equate. They are the same thing. So you now have that x is equal to 1 here. Now for this now, y is equal to 1 also. Y is equal to 1. Now t is equal to, sorry, z please. Z is equal to minus 2. Therefore, if you now turn it to like this, we have 1, 1, and then minus 2. So when we have this, let us compare here. This one has minus 1, of course, it's off. This one has minus 1 minus 1 is off. This one have 1, 1 minus 2, which is the correct thing. This one is off already. Therefore, it is the option C. For details on how to solve questions on dimension, I also have the link in the description below. We'll take another question. Sixth question says, a car of mass 1500 goes round in a circular curve of radius 50 meters at a speed of 40 meters per second. The magnitude of the centripetal force on the car is dash. Solution. Now, before we go, please, if you have not subscribed to this channel, please do me this favor. Hit the subscribe button, turn your notification bell on, because I'll be sending questions from today until the end of the JAMB question. Let me also inform you that those that will write day 1 and day 2, I will track their questions, compile it, and then make video, so that those that will be writing from day 3 onwards, they will leverage on what the other people have been asked. Now, let us solve this. Now, mass of the car is 1,500 kg. It goes on in a circular curve of radius. Radius of this curve is 50 meters. Now, at the speed of v, which of course this speed is linear speed, 40 meters per second. Now, the centripetal force is what we are looking for. Now, the formula, there are several formulas for centripetal force, but because of the parameters given to us, centripetal force is mv squared all over r. Now, where m is the mass of the body, v speed of the body, r is the radius of the path or the distance, f is the centripetal force. Now, if you substitute, we have under m, we have 1,500 multiplied by v. V is 40 squared divided by 50, which will give us, and of course, if we replicate our 1,500 here, 40 squared is 16,000 all over 50. Now, if we do the necessary calculations there, we mean, sorry, it is 1,600, please, not 16,000. Now, if you multiply this, we now have 1,600 multiplied by 1,500. It will give us that the centripetal force is 2400 all over 50. Now, this 0 can cancel this 0, which will now give us 240,000 divided by 5 will give us 48000. Now, at this point, this one is in ordinary form. Put it in standard form. If you put it in standard form, you will now have that the centripetal force is equal to 4.8 multiplied by, now we move 1, 2, 3, 4. If we move like it will give us this 4.8 times 10 raised to the power 4 Newton. There are two 4.8s here. Take a closer look at the option. This one is raised to the power 4, this one is raised to the power 3. Don't get deceived, please. Now, this one is raised to the power 4. We now have that the correct option there is option B. Now, we'll take one or two more questions and then we wrap it up. This question, this one is under dimension also. Please, you must get prepared for dimension. That is the truth. You must get prepared for dimension. I'll take this one now. This one says the expression m raised to the power a, r raised to the power b, t raised to the power c. When a is 1, b is 2, c is -2, is the dimension of which of these has this dimension. Now, all we need to do is, with solution, we bring this m, a, l, b, t, c. Now, we factor in these integers here. We now have m, of course, m is raised to the power 1. You can just leave it there, or write just m. Now, l is 2, t is minus 2. Having done this, the next thing now is to rearrange this. Now, if you rearrange this, and of course we have m, l, of course, if you have m differently, we have lt raised to power minus t. Remember, this one is remaining, multiplied by l. This one is acceleration. While this one is mass, this one is acceleration, while this one is distance. Now, we group this now. This one is mass times acceleration multiplied by distance. That is what this thing means. Mass times acceleration multiplied by distance. Now, mass times acceleration is force. These two, that means mlt raised to power minus 2 dot l. This one is force, while this one is distance. Now, we have which of the parameters has the expression for force times distance. Force times distance. If you check this one is force, is out. Energy. What is the expression for energy? We leave this one and then move to this one. Acceleration is just, of course, acceleration from F is equal to ma. A will give us F over m. No, it's off. Power. Power has IV. Power is IV. And of course, power is off from this. Now, this one that has this is, of course, force times distance. We all know that force times distance is work. And work, this one is in watts. Energy is in joules. So either work or we have energy. These two, they have the same expression. Force times distance. Another parameter that has the same expression for this is moment of force. Moment of force, and of course, moment of force is force times perpendicular distance. So these three, in case it doesn't come like this, in case you have a moment, please, moment, either you take moment, or if you see work, you put it, or if you see energy, you take it. So 1, 2, 3, they have the same expression, they have the same SI unit, and they have the same dimension. So the dimension, the correct answer option here is option B, either energy or work or moment of force. Okay, the last but not the least question. Now this question says, a satellite revolving around the Earth is kept in its orbit by centrifugal force only, centripetal force only, centripetal and frictional forces, while D is centripetal and centrifugal forces. Now, we explain them one after the other. Now, the centripetal force and the centrifugal force, they are somehow related, but opposites in meaning. Now, let me start with the centripetal force. Centripetal force is the force that keeps a body moving around a circular orbit. Assuming we have a body moving in this orbit. Now, if this is maybe the tangential velocity there. Now we have this as the center. Now from here to here is R. Now the acceleration of this body is towards the center of the circle for centripetal force. While for centrifugal force, it is an outward force. Though moving in a circular orbit, but it keeps it tends to move outward, drag the body outward, whereas centripetal force moves around the circle towards its center, whereas centrifugal force is outward from the center. Having explained this, frictional forces does the forces that act between two surfaces in contact, and of course is out of the game. Now between these, the only force that will keep a body rotating in around its orbit is the centripetal force. Therefore, the correct answer option there is centripetal force. On no condition should you put centrifugal force. Centrifugal force, though it's moving around a circular path, but it tends to move the body outwards from the center. All right, this is where we'll draw the lesson to an end. For more lessons, please, there is a link in the description below. It will have a WhatsApp group. Please click on that link. It will now welcome you to our WhatsApp group. Please, if you find this lesson interesting, please hit the like button for me. Share this video with your friends, because millions of people do not have access to this. They need to have access to this so that if you're writing exams, you'll be confident in yourself. Do not forget to hit the subscribe button if you have not subscribed to this channel. Thank you. See you tomorrow when I will bring in another exciting topic. Bye.